Welcome. Today, we're going to cut right through the buzzwords and the hype surrounding artificial intelligence to look at the actual mechanics of the technology. For decades, whenever we heard the letters A and I, our minds instantly jumped to futuristic robots, laser beams, spaceships, the whole shebang. But the reality? Well, it's actually far more grounded, incredibly fascinating, and it's actively processing data right inside your pocket as we speak. So today, we're going to break down exactly what this technology is, how it works, and why it absolutely matters to you. So here's our roadmap for today. We'll start with what AI actually is, take a quick look back at its history, see how it's currently powering your everyday life, and then we'll weigh the massive benefits against the very serious risks. Let's get to it. Section 1. What is AI? Let's ground this concept in something we're all familiar with. When you break it down literally, artificial just means human-made, and intelligence is thinking power. Put them together, and you get a branch of computer science that's dedicated to creating machines that think and act like humans. Now, at its core, this represents a massive shift in how we approach computing. Historically, computing has been instruction-driven, meaning a machine does exactly what a human explicitly codes it to do, step by step. Actually, think of it like a strict recipe. AI, however, is outcome-driven. These systems find their own path to a goal. By using complex algorithms and neural networks, these machines don't just calculate numbers. They comprehend patterns, analyze variables, and act with a level of cleverness that really mimics human cognition. Now, the crucial point here is understanding how that learning actually happens. Think of it kind of like a mirror. As humans, our intelligence grows organically, right? We learn to navigate the world through pattern recognition, built by seeing, hearing, and physically experiencing our environment. Machine learning, which is a major subset of AI, builds its own neural pathways in a remarkably similar way, but entirely digitally. Instead of physical senses, the machine is fed massive amounts of training data. It constantly analyzes that data to adapt, optimize, and improve its own performance. It's essentially teaching itself without a human ever needing to go in and rewrite its code. And here's a quick, pretty interesting technical fact for you. If AI is the brain, Python is the language it thinks in. It's currently the most popular programming language driving today's machine learning models because of its vast libraries and intuitive syntax. Ironically, it's this foundation of keeping the coding language relatively simple that allows these machines to build such incredibly complex self-learning architectures. Moving right along to Section 2, the interesting history. Let's see how this all started. You'd be forgiven for thinking this tech just popped up overnight, but the seeds were actually planted decades ago. Back in 1955, American computer scientist John McCarthy officially coined the term artificial intelligence, and by 1956, the very first major conference on the topic was held at Dartmouth College. Amazingly, the scientists at that conference genuinely believed they could solve the entire problem of artificial intelligence over a single summer vacation. Obviously, they wildly underestimated the challenge. And while they spent the next few decades tinkering away in labs, pop culture movies like The Matrix and The Terminator stepped in to shape public perception. They really gave us that classic and often scary Hollywood expectation of walking, talking rogue robots. All right, Section 3, AI in everyday life. Let's bring this right back to your current environment. Leaving Hollywood behind, the reality is that these predictive algorithms are already deeply embedded in our daily routines. And the seamlessness of these tools is exactly what makes them so powerful. Apple's Siri and the Amazon Echo, they utilize natural language processing to instantly parse and react to human speech. Google Maps relies on heavy predictive modeling, taking in real-time data from millions of phones to calculate traffic density and intelligently route you around it. Tesla Autopilot leverages computer vision to navigate physical spaces. Even video games like chess use reinforcement learning, constantly evaluating billions of potential outcomes just to predict and counter your next move. It is literally everywhere. And the versatility of this core tech is just staggering. It goes way beyond our consumer gadgets. The exact same predictive algorithms that banks use in finance to instantly detect credit card fraud are being tweaked and applied in agriculture to predict weather patterns and optimize global crop yields. From transforming diagnostics in healthcare to automating massive supply chains in manufacturing, these neural networks are quietly doing the heavy lifting across almost every major global industry, saving massive amounts of time and resources. Which brings us to Section 4. The big benefits. Why go through all this trouble to build these systems? Well, what's really interesting about this slide is how machines solve our very human limitations. First, AI drastically reduces the margin for error.
achieving a level of precision in complex tasks that humans simply can't maintain. Second, it accelerates decision-making. It can process millions of data points to react in a fraction of a second. But the absolutely crucial advantage? Endurance. Machines don't need sleep, they don't need coffee breaks, and they don't lose focus. They operate continuously, solving human problems and analyzing data around the clock, without ever getting tired or distracted.
Now for Section 5, the serious risks. We need to look at the flip side of this coin.
With any monumental shift in capability comes an equally monumental set of challenges. And there's no sugarcoating it. There are legitimate threats here. First is the economic impact. The very automation that makes AI so efficient presents a serious threat of widespread job displacement and unemployment across various sectors. Also, sustaining that automation isn't cheap. These are remarkably complex systems requiring massive computing power, energy, and infrastructure costs just to build and maintain. Finally, there is the existential threat. This is the ultimate sobering consequence of building a system designed to rewrite its own rules. If autonomous machines are eventually allowed to make high-stakes decisions without strict human oversight, the unpredictability of those outcomes poses a very real danger.
Google's CEO, Sundar Pichai, framed this balancing act perfectly. He compared AI to humanity discovering fire or electricity. We learn to harness those powerful, frankly dangerous forces for our ultimate benefit, while simultaneously having to invent strict safeguards to protect ourselves from their destructive aspects. AI is the exact same type of paradigm-shifting tool. We are utilizing it for tremendous advantages for sure, but we must actively engineer the safety nets required to avoid its inherent risks. It is both a miracle of human invention and, without a doubt, our most profound responsibility. So, considering the undeniable power, the incredible versatility, and the inherent risks we've explored today, what do you think the future impact of artificial intelligence will ultimately be on humanity? Keep questioning, keep observing, and thanks for exploring this with us today. Catch you next time.